Hello everyone, I am Emre Koçyiğit. I'm a doctoral researcher in the University of Luxembourg. If you started to study machine learning, you will hear different terms of learnings. Of course, you don't need to know every details of each one, but at least you should know them in high level. I assume you know supervised, unsupervised, semi-supervised, and reinforcement machine learnings, but there are more learnings. And these are transfer learning, distributed learning, federated learning, online learning, and association rule learning. Actually, there are more, but in this video, I will summarize these 5 learnings briefly to give you an idea about each one. Let's start. As you estimate, machine learning is not only for educational projects or research. Today, so many machine learning based products are available. Real life world requirements data cause some problems or challenges for machine learning models. Of course, machine learning community is producing various solutions for these problems. Actually, all of these learnings in machine learning are created to solve different type of problems in different structures. Let's look at one by one, and at the end you will learn what all these learnings and their differences, their relations, etc. Let's start with transfer learning. For some cases, data can be expensive, difficult to collect, or rare. Or even if collecting data is not expensive and we are able to collect all related data, training the model with all possible data can be too long or inefficient in terms of our machine's computational capacity. At this moment, transfer learning provides a very good approach. Firstly, use pre-trained model in a new problem. The idea is simple, so you don't have to explore the America again from the beginning. If someone has discovered and created a map, then you can use that map to discover new areas. But of course, the problems should be related. You cannot use any well-designed and successful model for your problem. A classic example, people who knows playing piano can learn guitar faster than other people who doesn't know any instruments. The idea is similar in transfer learning. You can use pre-trained models, but remember, problem structures should be related. For this example, if the new problem is learning playing football or painting, then pre-trained model in playing piano will not be helpful for this problem. Let's think applicable machine learning project examples. For instance, image classification of recyclable objects model can be used in similar problems, like classifying delivery packages, different boxes, or classification of different objects. That's all. Now let's see distributed learning. Here we have another problem. Now we want to collect more data, big data. Maybe we will develop the pre-trained model in the previous example. And traditional ways, one workstation are not enough to manage large data or large models. We have also some memory restrictions. Also, we need some high computational power, and sometimes because of this complexity, training can be too long. At this moment, distributed learning provides an efficient approaches. Main idea is allocating learning process into several nodes. Multiple nodes mean multiple processes which can work parallelly to decrease the model training time. Generally, deep learning training time is longer than machine learning model training time, so distributed learning techniques are more needed in deep learning training processes actually. And major methods are data parallelism and model parallelism. Data parallelism is briefly use same model and split the data. Of course, each node should update synchronously, and it's easier and more efficient than model parallelism in most cases actually. And for the model parallelism is use same data and split the model, then share the global parameters with other nodes. Of course, it is harder, especially if your data is too large. Let's see an example. I took it from Microsoft Azure tutorial about distributed learning. You can check the link in the description part. As you see, this is image classification project. The idea is splitting cat and dog data sets to subsets, then use the same CNN, same convolutional neural network model for the problem. This is data parallelism. Now, another exciting and important hot topic of machine learning is federated learning. In some cases, companies, organizations can train models centrally, but serve and store them locally. And a classic example is user modeling and personalization in mobile. Let's assume that we are Google and we developed a next word estimator application. When someone writes weather is bad and I am blah blah blah, our application offers sad, nervous, etc. We want to train our machine learning model with data from different devices, but our application will be personalized one. So what are the possible problems here? We have two major problems. First one, we want to provide best service, best results with our models to users. However, their devices has some limitations, especially in terms of computational power. And secondly, we want to provide personalized service and preserve privacy of each user. At this moment, federated learning concept provides solutions. By the way, devices can be smartphones or hospitals in a network. The federated learning is quite a hot topic. I want to mention some of the challenges because this is a good example of understanding how machine learning can be used in real life and what are the potential problems. I will not talk about all details, but some challenges, especially in this area. And the first one is expensive communication. In federated learning, the center of system needs to communicate with devices. Of course, it has some cost, and communication is usually expensive. Therefore, we need to reduce the total number of communication rounds and size of transmitted messages at each round. And another challenge is heterogeneity. As you estimate, devices can be iPhone, Samsung, or iOS, Android, different processors. So the system should be able to tolerate the heterogeneous hardware. Also, some of the devices can drop during the communication, so the system should be robust to this kind of conditions. And the last one, privacy concerns. These privacy concerns can cause loss in performance and can decrease the efficiency of the model. So we need to handle with this kind of issues. Different applications can need federated learning. For example, IoT network can use data of each element while keeping localization. Or another example, let's assume that we have drones and cloud system. Each drone can belong to a customer, therefore we can need to personalize behavior and decision of each drone. And federated learning can provide good solution for this problem. Okay, I think it's enough for the moment. Let's continue with other ones. Online learning. Especially in educational machine learning projects, we trained our model with all dataset and test the model. And after the production, there is no more learning phase. So this is called batch learning. However, in real-life examples, models usually need to be fed with new data even after the production. In other words, in some cases, learning process should be incrementally proceeded in the fly after the production. And this is online learning. Sometimes it can be called also incrementally learning. Let me give an example. Let's think phishing website detection example. We have a machine learning model for classification of phishing and legitimate websites, and this is supervised learning, so we have labeled data and trained our model. However, new attacks, new phishing websites are created every day, so we need to feed and train our model in the production. So we can design online learning structure and get new data and train our model while it is in the production. Okay, we saw online learning and machine learning, and now the last learning is association rule learning. Actually, this is different from the previous ones because previous ones are mostly related with the learning structure. However, association rule learning is an unsupervised and rule-based machine learning technique. And basically, it provides to see associations, patterns, or relations among the variables and classes. A classic example of association rule learning, market basket analysis, or customer segmentation. By the way, sometimes it is called as association rule mining. Think that each of basket belongs to a different customer, and customer 1, 2, 3, and 4. This is our data set, and we know that customer 1's basket contain, for example, bread, cheese, egg, and milk. And other baskets have some drink, meat, vegetables, etc. You can easily see there are some patterns, some associations. For example, whenever someone buys egg, they also buy milk. This is quite a strong relation. We can easily create some rules based on this relationship. And the second one is two customers add meat and a drink to their baskets. So we can say that there is an association between these items. However, customer 3 added meat but not a drink into the basket. So we can estimate the meat drink association is not strong as much as egg and milk association. Also, you can see that customer 2 and 4 have nearly same basket. After finding associations, we can also make some customer segmentation. And of course, with a few items and baskets, it's easy to analyze and find relations. However, when it's getting complicated, thousands of baskets and millions of items, association relearning provides efficient solutions. By the way, you can think items as variables and you can transform this problem to other problems. For example, items can be genes and the customers can be chromosomes. That's all for this video. We saw transfer learning, distributed learning, federated learning, online learning, and association relearning in machine learning. Each of them is a huge topic. If you are interested in any of them, you can dive into these topics and use them in your machine learning project. Thank you for the watching.